Now, when you ask, for example, why two magnets repel, there are many different levels. It depends on whether you're a student of physics or an ordinary person who doesn't know anything or not. If you're somebody who doesn't know anything at all about it, all I can say is that there's a magnetic force that makes them repel, and that you're feeling that force. And you say, but that's very strange, because I don't feel kind of force like that in other circumstances. When you turn them the other way, they attract. There's a very analogous force, electrical force, which is the same kind of a question. And you say, that's also very weird. But you're not at all disturbed by the fact that when you put your hand on the chair, it pushes you back. But we found out by looking at it that that's the same force, as a matter of fact, the electrical force, not magnetic exactly in that case, but it's the same electrical repulsions that are involved in keeping your finger away from the chair, because everything's made out of its electrical forces in microscopic details. There's other forces involved, but this is connected to electrical forces. It turns out that the magnetic and the electric force with which I wish to explain these things, this repulsion in the first place, is what ultimately is the deeper thing that we have to start, what we can start with, to explain many other things that looked like they were, everybody would just accept them. You know, you can't put your hand through the chair, that's taken for granted. But that you can't put your hand through the chair when looked at more closely, why? That involves these same repulsive forces that appear in magnets. The situation you then have to explain is why in magnets it goes over a bigger distance than in ordinarily. And there it has to do with the fact that in iron, all the electrons are spinning in the same direction. They all get lined up, and they magnify the effect of the force until it's large enough at a distance that you can feel it. But it's a force which is present all the time and very common, and is in a basic force of almost, I mean, I can go a little further back if I were more technical, but at an early level, I just have to tell you that's going to be one of the things you'll just have to take as an element in the world, the existence of magnetic repulsion, or electrical attraction, magnetic attraction. I can't explain that attraction in terms of anything else that's familiar to you. For example, if we say the magnets attract like as if they were connected by rubber bands, I would be cheating you. Because they're not connected by rubber bands, I shouldn't be in trouble. You'd soon ask me about the nature of the bands. And secondly, if you were curious enough, you'd ask me why rubber bands tend to pull back together again, and I would end up explaining that in terms of electrical forces, which are the very things that I'm trying to use the rubber bands to explain. So I have cheated very badly, you see. So I'm not going to be able to give you an answer to why magnets attract each other, except to tell you that they do, and to tell you that that's one of the elements in the world of the different kinds of forces. There are electrical forces, magnetic forces, gravitational forces, and others, and those are some of the parts. If you were a student, you'd go further. I could go further. I could tell you that the magnetic forces are related to the electrical forces very intimately, that our relationship between the gravity forces and electrical forces remains unknown, and so on. But I really can't do a good job, any job, of explaining magnetic force in terms of something else that you're more familiar with, because I don't understand it in terms of anything else that you're more familiar with.